Welcome back again. If you have filled out the first three forms, then you have completed your prediction for hypothesis number 1, and it's time now to move on to hypothesis number 2. Let's take another look at hypothesis number 2. We are now hypothesizing plumb bobs hang down towards the center of a sphere, and they are not parallel to one another. Okay? And all risers on a single water level are the same distance from the center of that same sphere. So that is hypothesis number 2. I am not asking you to agree that this is correct. I am not asking you to say the reality works this way. Instead, all I'm asking is that you take the rules laid down by this hypothesis and apply them on the following diagrams to answer the questions that I pose. So if this is the case, what do we predict? We will then, once we have the prediction, we will then compare that prediction against measurable reality to evaluate the validity of the hypothesis at that point. But first we need the prediction. The hypothesis refers to a sphere, and I have indicated a sphere here with the center point O. I call that O, and I'm drawing the spheres as circles. So this is a side view. These represent spheres that go in and out of the screen, but the outer diameter of them is illustrated with circles. The reference sphere is black, and I have provided that the reference sphere might have a radius of 6,371,000 meters. So that will be the black sphere has that radius at center point O, and I will then be talking about another sphere, the red one, which shares that same center point but has a different radius. Here's the link to the form. I'll put the link to the form right there, and it'll also be down in the description. On there, we will ask, what is the radius R1? What is this distance from the center point up to this point along the red sphere, given that the reference black sphere has this radius and the red sphere goes out 5 meters further than that. Once you filled in R1 for that radius, let's do it again for a different sphere. Let's take a look at a green sphere now. This is a green sphere, and I will be asking on that same form, what is the radius R2 of the green sphere? Once again, the green sphere, we have a point somewhere on the green sphere that is 5 meters above the reference sphere, which was, once again, 6,371,000 meters in radius. So if I have the black sphere with this radius, and I have a green sphere that is 5 meters outside that at a given point, then what is the radius of the green sphere? And so that's the 2 questions, only 2 questions on that form. That's the form. It will be linked down in the description. Once you've answered those 2 questions, join me in the next video.